Hello, fourth year. This video will cover gradient calculation. All right, now I'm kind of hoping that that's not brand new to you. I hope that's something you've heard before. If not, you'll see it here. If it is revision material, hopefully we'll get through it fairly quickly. Um, Gradient is a way of measuring slope, okay? So if you think about diagonal lines, they obviously have different steepnesses, all right? If you think about walking up hills, if you're walking up a nice shallow hill, no problem, happy to do that. If somebody asks you to walk up Mount Everest summit, you might think that was a little bit of a challenge, yeah, because it's quite steep. So gradient gives us a way to describe steepness in mathematical terms. It allows us to put a number to it, and that means that we can compare different steepnesses of different things and we can validate things. So, for example, planning permission might require ramps to have a no more than a certain gradient. That's a way we can use it. Okay, so it's actually quite a simple calculation. Gradient is given the letter M. I've no idea why that is. I think it's something to do with the French origins of the word, but gradient is given the letter M, and gradient is the change in vertical height. I'll move that along. In fact, you know what I'm going to do? I'm just going to move that to the left. Oops. So change in vertical height, and we divide that by the change in horizontal distance. So the change in horizontal distance. If you think about walking up a hill, as you walk forwards, as you move up a hill, you're walking from left to right. Yep, you're walking forwards, but you're also walking up the way, aren't you? You're getting higher. So whenever you walk up a gradient, you're walking in two directions. So you're going on the vertical and you're going on the horizontal. If you think about your X and Y axis, you're moving along the X axis and you're also moving up the Y axis if you walk up a hill. So the gradient allows us to compare those two things through division. All right, so that's all it is. Now you'll be pleased to know that we can abbreviate this down to V over H, okay? As long as you get that right. Please, please, please get it in that order, okay? If you do H over V, you're going to get it wrong. It's V over H, vertical over horizontal, okay? Now, that first slope there, that first hill, it looks like Moss Street. If I want to calculate the gradient of Moss Street, the gradient, I'm going to do V over H, and that is going to be 10 over 150. Now, you should be able to simplify that fraction by taking out a common factor of 10, and you'll get 1 over 15. Okay, that's absolutely fine. That's gradient, 1 over 15. Okay, the other street there, it looks like Ross Avenue, so we're going to call that Ross Avenue. Let's calculate the gradient of Ross Avenue. Again, I write M equals V over H. That is 3 over 60. I hope you can see where I'm getting those numbers from, the vertical height and the horizontal distance from that hill. And in the previous question, it was the very same. 3 over 60 simplifies. If we take out a common factor of 3, we get 1 over 20. Okay, so that's the gradients calculated. That's perfectly valid. I could stop the question there. But if someone were to come along and say, which hill is steepest, you might well be able to do that just by looking at the fraction. Yeah, which would be great. But sometimes, if it's less obvious, it's much easier if we have a decimal equivalent. Okay, so the decimal equivalent of 1 over 15, we just do the division. You can use your calculator for this, and you'll get 0.0666, and that keeps repeating. I'm just going to move that down a little bit. Yep, so that would round to 0.0, will we give it to 3 decimal places? So 0.067, that's quite a shallow hill. 1/20, the decimal equivalent over here is 0.05. That's approximate, well, that's an exact value actually, don't even need to round that one, that's that done. Okay, so 0.05. Hopefully you can see it's quite easy now to compare those two things. Which is the steepest? All right, well, the steepest hill is the biggest number. Steepest is the largest number, and the largest number, I shouldn't say largest number really, should we? It should say largest gradient. And the largest gradient, when we've got them in decimal format, it's really easy to tell, is 0.067, which is Moss Street. Okay, so Moss Street is the steeper of the two streets, okay, because it has the larger number. So, summary of things for you here. Gradient is the change in vertical height over the change in horizontal distance, okay, V/H if you want to abbreviate it. Take the values and do the division, okay. You can stop at a fraction if the question asks you, all right, so that would be here. You can stop there, that's perfectly valid, all right. If the question asks you to find the steepest whatever, then you have to actually do that division. So you do 1 divided by 15 to get your decimal, and in this case we did 1 divided by 20 to get our decimal, okay? So you might be asked for decimal. It might be more useful to have the gradient in decimal, all right? But that is gradient, okay? It's fairly straightforward, fairly simple. Just take your time with it. The thing that most people will get wrong is they'll do these two round the wrong way. So you'll put horizontal on the top and vertical on the bottom. That's just plain wrong, and it'll get you the wrong answer. So please don't do that. Be very careful when you're working your way through these things. All right. If you have any questions, if you're unhappy about anything I've done there, please get in touch, Glow email or Teams chat. It's helpful if you can tell me at what point in the video you stopped understanding, and I can cover that for you. That's really no problem. All right. Good luck with the questions. I'm hoping it's revision and it's fairly straightforward for you. The next phase of this is to work gradient and Pythagoras together.